induction motor. He built it in 1887 to show that it is possible to produce a very efficient machine based on polyphase current. Here we have again two-phase current passing into these four coils and a rotor which is rotated in the same way as the spinning egg, but to get a much stronger action required for the motor, here we have a short-circuited coils into the rotor. When we pass the current, the motor operates and its speed is nearly 3000 revolutions per minute with a 50 Hz current. It's a very powerful motor, over half a horsepower. In 1882, Tesla discovered the idea of rotating magnetic field produced by two-phase current. Here is the machine which is actually designed to show that two-phase currents, and it contains two coils. The current, two separate electrical circuits. One coil is going through those two rings into the external circuit of the one phase, and the other coil is going through the another two rings to the another phase circuit. Two-phase alternating currents are fed into four coils. When we produce two phases current, they will in combined action produce the rotating magnetic field. And we can illustrate that by rotating the generator, and that will produce the rotation of the magnetic needle. So indirectly we see the rotating magnetic field effect. This is a hydraulic analogy of Tesla's rotating magnetic field and induction motor. When we produce the movement of piston in the way that two-phase current are produced by the generator, we will produce the rotating magnetic field. So you can follow the movement.
He actually
of
says that the pistons act like two-phase alternating current.
tubes. And by observing the rotation of the triangle, you can see the way in which the rotating magnetic field causes induction motor rotor to rotate. In 1893, Tesla showed his alternating current system, induction motors, and various machines. Here is an experiment which he performed at that exhibition. Two-phase alternating current. This is one phase current, another phase current, and here we have four coils. Those four coils produce a strong magnetic field, the rotating magnetic field. And that rotating magnetic field is going to rotate any metallic object which we place in it. Here we see an object in the shape of an egg. Induction motor doesn't require any connecting wires in the rotor, and that is that famous motor without brushes, which Tesla wanted to produce. Tesla's alternating current motor is a part of a whole system of polyphase currents. That system consists of a generator, like the one we have here. It is driven by water. Mechanical energy of water is converted into three-phase alternating currents. Those currents carry energy through the wires, first as a low voltage, then as a high voltage, with very low loss. We carry that energy through the wires. We step down high voltage into low voltage and distribute those currents to various loads, for example, electric motors.
Should be charging some batteries and that shit.
Is an example of generation, transmission, and utilization of electric energy.